It seems like every time I post a new video I have to bring out the teaspoons, and this time is no exception. So for Walter Dome, the Little Season, and Alex Carlin here, we have problem with my orthographic view, and how do orthogonal view deal with loss of vision at long distance? And also down here, you must define how loss of vision works. Now Walter Dome used his own excuse for something and want me to define his excuse that he already admitted to be true. Nope. I said it depends on zoom level, aperture, pixel size, several things. So no loss of vision over distance. And here the Little Season, how does your math work? No math included. Also here I pointed out my eye level and the height of the turbine. Explain the math behind this. No maths. And again I ask, what maths are you using? Nope. How do you measure below my eye level of 22 meters? You'll see in a second. I'll try to help you. Does it appear like that because the angle dips according to the rules of linear geometry used by a theodolite? No. How do you calculate the dip? What dip? You sound desperate, like someone who doesn't understand how theodolites work. I never said anything about the theodolite. I used a camera. A theodolite, a bubble, angle of dip, all uses the same math of linear geometry. Wow, this is most impressive. Okay, so it goes on and on here, and I explained to them that I can try to make this by their own. And already here they have been looking into Gary Vybenga's videos and say that he has explained it so many times. And yeah, I'm not going to read it all, but it goes on. So first of all, and of course I would like to know which one of these drawings that Gary has made does explain anything about where the line of sight goes in my observation. This one here about parallax, there's no parallax in the single frame photo. All these rubber bands and drawings, none of these explains anything about my observation, so I don't know where I had that from. So this is the photo I shot with my eye level at 22 meters. That's about halfway up that lighthouse, which is 47 meters. So yeah, these turbines are 325 meters tall, 68 kilometers away. And you said I used a theodolite. Nah, this is my camera, Canon EOS 7D Mark II. And that's my tubes with water. Not only that, I have a digital level on my camera and a bubble here. So just to make sure it shoots straight ahead. About 1.5 meters across there. And my camera. That's my setup. No theodolite. So if this line here is my eye level shooting straight out, what dip are you talking about? What loss of vision would you have here? You see every single blade on the rotors down here. So nah. And then of course, if the Earth was flat, I will be standing down here and looking straight into that island. The hill they're standing on is 175 meters and the top of the turbine is at 325. So what loss of vision goes here? And this is orthographic. Yeah, I know that, but this is to show where my line of sight goes. So if any of you guys can show me where my line of sight is here to make my observation looking down towards the top of the turbine, which I see below my eye level, how this magically bends up here, that would be great. I would also like to know how this loss of vision over distance is supposed to work. Any definition, any drawings, any something, just something to show for, not just words. Because if the Earth was flat, this is what my observation would look like. Here's the lighthouse, and there's the turbine. It would be over here. This is what it actually looks like. I can see the top of the turbine here on the curved earth with a small bit of refraction which actually exists. So how does loss of vision take something from up here down there? Does loss of vision make something sink down? Loss of vision just sounds like something disappearing into a fog or something. Please explain. Because again here on the orthographic view, I should be staring into this hill. So loss of vision, does it just down here, or what is it? Something must happen here. Does it sink down into the ground, or what is it? Loss of vision, please elaborate. And when you're talking about orthogonal view, I'm also making a video of that, orthogonal versus perspective. But that doesn't have anything to say, because we can see things in perspective from here. That's a flat one, and here. So if we go to orthogonal, that's this one. No change, no magic. Orthogonal and perspective. And camera, perspective. This is perspective. So yeah, there's no change between perspective and orthogonal. Nothing happens over here. Sorry. So again, if any of you, Vaulted Dome, The Little Season, or Alex Carlin want to burst out of your fearless keyboard warrior bubble, please take a screenshot of this and make your own video. Just don't come into someone else's comment section and think you have the solution for everything, because you don't. I need a visual answer, not just worthless opinions. Don't be a Gary. Bye.